Okay, this video is going to be a quick review on multiplying and factoring. So if we think about what we know about multiplication and factoring from elementary school stuff, we know things like 6 times 3 are factors of 18 because 6 times 3 is 18. So if we factor 18, we're breaking it into numbers that multiply to equal it. If we're multiplying, then we're multiplying two factors to go back to this. So if we look at a simple problem like this, 12 times 13, this is really the same thing as 10 plus 3 times 10 plus 2. And if you think about how you actually compute this, if we're setting it up the long division way, we do 3 times 2, and this is 3, not times 1, but 3 times 10. And this is 10 times 2 and 10 times 10. So we're seeing this as 10 and 3 and 10 and 2, which is what we have up here. If we transfer this to a model here, we can kind of look at the same math right here. So we've got a length of 12 that is broken into a length of 10 plus a length of 2. Then we have another length of 10 plus a length of 3. And if we want to find the area of that, that's like the product of it. So think of this, these are the factors. 12 and 13 are the factors of whatever this is here. So if we did this piece here, the area of this piece will be 100 square units. The area of this piece is 10 by 3, so it'll be 30 square units. The dimensions of this one are 2 by 10, so this will be 20 square units, and the dimensions of this are 2 by 3, so this will be 6 square units. So when I add this all up together, the whole area was 156 square units. So if we think about it, 12 and 13 are factors of 156 because when I multiply 12 by 13, I get 156. Okay, so we're going to take this to algebra. So now we have these numbers here, 2x plus 1 times x plus 4. But still think of it, this right here, x actually is something. So this is actually just a single number times another single number. So just like we have over here. Think of this as a 2-digit number. This part here plus 1 and this part here plus 4. Kind of like how we had 10 plus 3 and 10 plus 2. So we should be able to make a similar model. So what I've drawn here is the model for that. So we've got 2x plus 1. So if we look here, we've got a distance of x and a distance of 1. And on the other side, we have a distance of x and a distance of 1, 2, 3, 4. And if I start looking at the area of this, well, if I have x and x, I'm going to get this little block here, which is an x squared. We're going to get another one here. This length by 1, this is an x, and so on. So we can fill in all of our boxes. What you see in red is more something like this. So I'm treating this whole thing as 2x and this as 1. Because if you look here, I've got 2x plus 1. So it's a distance of 2x plus 1. And this length here is a distance of x plus 4. So if we look at it, we can look at it this way. We can calculate each piece. So x squared, x and 1 is x, 1 by x is x. All of these are x blocks. And all these are 1 by 1 by 1. Okay, we can calculate it that way. So we'll get 2x squared, we'll have 8x here, we'll have an x here, and we'll have 4. Or we can go to a more generic rectangle, which will be the same thing. This will be 2x squared, this will be x, this will be 8x, and this will be 4. Notice how these numbers are the same thing as these numbers here. It's just this is a little bit simpler, so we're moving to this. Some things I want you to notice in this form here that are going to help us when we work backwards is that the diagonals of this happen to be the same product. So 8x times x is 8x squared, and 2x squared times 4 is also 8x squared. That's just kind of a cool pattern that happens. This doesn't really have anything to do with the problem, but it's a cool pattern that happens. So let's say I want to work backwards. So this, again, these are the products of, this is a product of the sum, which would be 2x squared plus 9x. So I've got 8x here and 1x here, plus 4. So this is a product of this. So these are the factors of this. So if I ask you to move from the sum to this form, that's called factoring. So this time, let's pretend I give you what's inside and I have to ask you to find the outside. Well, if we think about this, if we have an x squared here and we have a 2 here, okay, that always ends up happening. I always have my x squareds in this corner and my 1's down here. Notice my x squareds end up here and my 1's over here. And then my x's get split between here. So see, there's some x's here and some x's here. So I've got 3 x's to split up between these 2 spots. And what you can think about if you're using this rectangle is, well, I noticed last time that the diagonals always equaled the same thing when multiplied. So the diagonals here, this one multiplies to 2x squared. So this one's also going to have to multiply to 2x squared. So what goes here and here that will multiply to 2x squared? So we can kind of think, what 2 numbers multiply to equal 2, but they have to be a total of 3x. So they multiply to equal 2, but they add to equal 3. If we think about that, that's going to be 2 and 1. So if I put 2x here and 1x here, 2x times x is 2x squared, 2 times x squared is 2x squared. That pattern happens, and I've got a total of 3 x's, which is what I was supposed to have here. Then all we have to do is find our side lengths. So if this is the length of, what's that going to have to be a length of? So that this is 2x, this side by this side is 2x, and this side by this side is x squared. Well, if we think about what they have in common, they have an x in common. And if this length's with x, this one has to be 2. And if this length is x, this one has to be x as well. So that x times x is x squared, and 2 times x is 2x. If we look over here, this has to be 1, and if this is 1, this makes this 2, and so on. This would also have to be x, but notice how this side is the same as this. We don't really need that. So our side lengths are this times this. So x plus 2 times x plus 1 is the same thing as x squared plus 3x plus 2. And if you go back and check this and you put this in a rectangle and you multiply it, you'll get this. Okay? That's one way we can think about it. We can also think about factoring if we just use a little bit of logic here. So if we know that factors always are going to end up like this one here, I know that this spot here has to be x and this has to be x, so that x times x gives me x squared. And I know that this spot here and this spot here have to multiply to equal 2. So I can kind of guess and check a little bit here too. I was like, well, numbers that multiply to equal 2, that's 2 and 1. So if I try this, and let's just make these both positive to try it, and I multiply x times x, that's x squared, 2 times 1 is 2, 2 times x is 2x, and 1 times x is x, and I get x squared plus 3x plus 2, so it worked. Okay, if you want to check it this way, that's fine. You can also put it back in a rectangle to check it. So let's try another one here. If I give you x squared minus 5x plus, say, 6. Okay, I can figure out what it is in a rectangle, but I can also just think through this too. Well, I know this has to be x and x, so that those two multiply to equal x squared. And I know this spot times this spot has to equal 6. So let me try some numbers. Let's try 3 and 2. And I'm going to try a negative number here, and let's try a positive number here. So x times x is x squared, 3 times negative 2 is negative 6, 3 times x is 3x, and negative 2 times x is negative 2x. Well, if I look here, this is kind of a problem because that's x squared, and that's x, and that's minus 6. So these two numbers do not multiply to equal that. So let's try this instead. I'm going to make this one a negative and see what happens. So this time I've got x squared, negative 3 times negative 2 is positive 6, and negative 3x, and a negative 2x, and that is negative 5x, and that one happened to work. So these two numbers multiply to equal that, so that is what it is factored. So this way is kind of easy too. You just kind of have to guess and check and play around and see if the numbers work, and so on. Or you can go back to this rectangle method because this will also work. So it totally depends on the problem, and it's up to you if you want to factor just kind of by guessing and checking, or if you want to use the generic rectangle.